Assalamualaikum and good day everyone. So this video is the continuing from video number 1. Okay, lecture number 1 we discuss about equation of motion for translational motion. So in this video we will learn equation of motion for rotational motion about a fixed axis. Okay, when a rigid body rotates about a fixed axis perpendicular to the plane of the body at point O. Okay, so as you can see there, the body's center of gravity G, so look at G, move in circular path of radius RG. Okay, so look at RG. Thus, the acceleration of point G can be represented by a tangential component which is AGT here and AGN. Okay, so AGT is the tangential component and normal component is AGN. Okay, so AGT, formula for AGT is equal to RGA, and formula for normal component AGN is equal to RG omega square. Since the body experiences an angular acceleration, its inertia creates a moment of magnitude IQA, IGA equal to the moment of the external forces about point G. Thus, the scalar equation of motion can be stated as Fn equal to MAGN equal to MRG omega square, and force tangent, summation of force tangent is equal to MAGT equal to MRG alpha, and summation of moment at G equal to IG alpha. Note that summation of moment at G may be replaced by a moment summation about any arbitrary point. Summing the moment about the center of rotation O yield summation of moment at O equal to IG alpha plus RGM AG equal to IG plus MRG square alpha. Okay, this is from the parallel axis theorem. IO equal to IG plus MRG square. Okay, therefore, the term in parentheses represent IO. Consequently, we can write the three equations of motion for rotational motion of the body as first, Fn equal to MAGN equal to MRG omega square. Second, summation of force tangent, okay, equal to MAG equal to MRG alpha, and third one is summation of M at G equal to IG alpha, okay, and summation of moment at O, okay, at any point equal to IO alpha. Okay, so point O can be at any point other than point G. So remember, IO equal to IG plus MRG square. Okay, parallel axis theorem. So how to solve problem on rotation about a fixed axis. Okay, procedure analysis. Problems involving the kinetics of a rigid body rotating about a fixed axis can be solved using the following process. Okay, so remember, this is the process how to solve question on rotation about a fixed axis for rigid body. Okay, first, establish an initial coordinate system and specify the sign and direction of AGN and AGT. Okay. Next, draw a free body diagram accounting for all external forces and moments. Okay, this is important. Show the resulting I alpha, typically on separated kinetic diagram. Okay, so you will have two diagrams. First, free body diagram, and second is kinetic diagram. Okay, and third step is compute the mass moment of inertia IG or IO. And next, write the equation. Write the three equations of motion and identify the unknowns. And then solve for the unknowns. Okay. Use kinematic if there are more than 3 unknowns. Okay. Tips. Since the equation of motion allow for only 3 unknowns. Okay, let's move to the example 2. Okay, let's read together. A rod with mass of 20 kg is rotating at 5 radians per second at the instant shown. A moment of 60 Newton meter is applied to the rod. Find the angular acceleration and direction at pin O when the rod is in horizontal position. Okay. So the question give moment and also omega. Next, the question give the length of the rod and also mass equal to 20 kg. Okay, next we move to the solution. Okay, first free body diagram. Draw free body diagram. Rod and then at point O. Okay, so O, T and ON. Okay, first label direction OT and ON. Next, at point G, okay, the center. Okay, the center of the rod from 1.5 meter. Draw G and then weak force. Okay, and also direction of movement. Okay, so next, draw kinetic diagram. Okay, label for alpha RG and omega RG, and also label IG alpha, which is label the acceleration, angular acceleration of the rod. Okay, next, write the equation of motion. So since this motion is rotation at fixed axis, so we have two component of force, normal and tangent component. So first one is normal component equal to MAN. Okay, we know that AN equal to RG omega square. Okay, so M is 20, RG is distance from center of the rod to the fixed axis 1.5, and then omega equal to soalan bagi tadi radian per second. Okay, and then you will get the answer for Fn. Okay, next for tangent component. Okay, so for tangent component, Ft equal to MAT equal to MRG alpha. We know that Ft equal to RG alpha. Okay. So, y direction of force at tangent is positive downward because follow from kinetic diagram. So M alpha RG is assumed to downward. Okay. So make sure alpha RG is same direction with IG alpha. So IG alpha is clockwise. So M alpha RG is moving downward. Okay, so that's why we assume downward is positive. Okay. Next equation is for moment. Okay, so we assume counterclockwise is positive, equal to IG alpha plus IMRG alpha RG. Okay, so M at O is equal to 15. Okay, is equal to 0.15. Sorry, there's an error here. Should be 20 here. Okay, equal to IG alpha plus MRG alpha. Okay, next using IG equal to ML square over 12. Okay, because it is root, and RG equals to 0.5 times 1. We can write here. Okay, and then substitute. You will get alpha and OT. Okay, summation of force at T. Okay, so in the next video we will learn equation of motion for general plane motion. Okay, if you have any question, please let me know. Thank you so much. Assalamualaikum and good luck.